All right, melting points also show a difference depending on how many hydrogen bonds you have. Okay, this is nothing that's not that obvious. The more hydrogen bonds you have, obviously, the higher the melting point. The less hydrogen bonds you have on your nitrogen, the lower the melting point. Nothing new there. Just something that we would expect. Solubility, also an interesting thing. Acid chlorides and anhydrides are too reactive to be used with water and alcohol. If you were to drop those into water, they react immediately. We're going to see this once we start talking about reactivities, but acid chlorides and anhydrides are not soluble in water. They react. All right. Esters and amides and nitriles are pretty polar solvents. They're actually used if you need a really polar solvent, but you can't use something that has a proton. So notice this term aprotic. So a very polar solvent would be an alcohol, for example. Okay, but what if you're doing a reaction that's a strong base? It's going to start plucking off hydrogens and deprotonating hydrogen. So let's say you want a polar solvent, but you don't want an acidic proton. Well, you would use one of these esters, tertiary amide, or a nitrile. They're polar and they do not have any protons on it. So that's when you would use solvents such as those. So solvents that are commonly used, ethyl acetate's a very common one, dimethylformamide, okay, or DMF for short. DMF is dimethyl and then a formal group, formamide. That is DMF, okay. Acetonitrile, and here's kind of a list of some of the common solvents, okay. Just to kind of, and it also even shows you the water solubility. All right, like DMF and DMA and acetonitrile are almost as polar as water, which is kind of interesting. All right, so that's pretty much it for the first part of this. The second part and the remainder of the videos are going to be on the reactivity of these compounds.